students, the topic that we are going to learn today is series and sequence. So let's get started. First of all, we need to know what are the topics that we are going to study in this section. We will be learning what is a sequence and what is series. So basically we will be giving you, we will be learning actually a basic idea or getting a basic idea of what exactly a sequence and series is. Alright, then there are certain types of sequences that we are going to cover in this section. Let's see what are those types. Okay, we will be learning about arithmetic sequence and series and geometric sequence and series. Finally, we will be learning about harmonic progression or harmonic sequence, and the last topic of this section will be the last topic of this section is arithmetic, geometric and harmonic mean of two numbers. So let's get started. Alright, first of all we need to know what exactly a series and sequence is. Now, a sequence or progression, so sequence is actually called progression as well, is an ordered list of numbers. The numbers in this ordered list are called the elements or the terms of the sequence. Or you can say that in mathematics we say that sequence is an ordered arrangement of numbers. Alright, so it's the numbers are written in certain orders. Alright, a series is what you get when you add up all the terms of a sequence. Alright, so series indicates the sum of the sequence, whereas sequence is an ordered list of number or particularly numbers that are arranged in certain order. Alright, I hope you have understood what exactly a sequence and series is. So let's move on to our next topic, that is arithmetic sequence. The types of sequences. Now firstly we will be learning about arithmetic sequence. Now an arithmetic sequence is a sequence of numbers such that the difference of any two successive members of the sequence is a constant. Now in order for a sequence to be arithmetic sequence, it is important that whenever a sequence is written, the difference of the two successive terms should be equal throughout that sequence. Then only we can say that this sequence follow arithmetic sequence. Now let's just take an example and understand it better. For example, I have written a sequence of numbers, that is 1, 3, 5, 7 and so on. It's an infinite sequence. Alright, okay, and it's an odd number sequence too. If I wanted to check that whether this sequence follows arithmetic sequence, what I'm going to do is that I'm going to find out the difference between two terms. Alright, between two successive terms. If I find out the difference between two successive terms and throughout the sequence that term is constant, okay, the difference of the two successive term is constant, so then only we can say that it follows arithmetic sequence. Now how it is done? Now it says that it's an AP, or you say arithmetic progression, because if I just subtract two successive terms, two terms from the sequence initially, that is 3 minus 1, or I subtract 5 minus 3, or I subtract 7 and 2, I take out the difference between all these terms, that is 3 minus 1, 5 minus 3 and 7 minus 5 and so on. The result I'm getting is 2. Now this 2 is basically constant throughout the sequence. Alright, so this is the common difference, and then out here we can say that it follows arithmetic sequence since the difference of two terms throughout the sequence is same. Now out here there are only four numbers are given, so you're checking according to this sequence. Now if it follows 2, so it will follows the 2 number will be followed throughout. Alright, so if any sequence is written and we need to check that it's an arithmetic sequence, we will be looking at the difference of two successive terms, and if the difference is constant throughout the sequence, we can say that it follows arithmetic sequence. Okay, note that in an arithmetic progression each term can be obtained from the preceding term adding the common difference. That is, let's say if I need to know the term that comes after 7, then what should I do? I will be add 2, that is the difference that I have told you right now, this 2. If I start adding it, I will be getting the next term and so on. Okay, now journal form of the sequence. Now if I need to know the journal form of the sequence of arithmetic sequence, so it's this: t of n, where t indicates the term, okay, is equals to a is denoted as the first term, a plus d, that is d is basically the common difference, a plus 2d, a plus 3d, so on to a plus n minus 1d. Now this formula is actually used where t is called the general term of the sequence, and the formula for obtaining term of an AP is this. So as I was saying, that this term, this formula, alright, this formula is actually used, this generalization is actually used to find number of terms. Now let's suppose if I need to find out 100 term or a 200 term of that particular sequence, if it follows arithmetic sequence, then I don't need to add that constant difference all the time and adding it up to 100 times to get my answer. Alright, I can simply use this formula and find out that particular term which is required. Okay, now out here the formula states t of n is equals to a plus n minus 1d. Okay, now a is basically denotes the first term of the sequence, d is the common difference, where n is the number of term required. Okay, so let's just consider an example and understand better. Okay, now the question says that show that the sequence 7 comma 11 comma 15 comma 19 comma 23 is an arithmetic progression. Also find its 27th term. Now out here the sequence is given to you, and they are asking you that you need to show that it's an arithmetic progression. Now we know that for arithmetic progression it is important that the difference between the two successive terms should be equal throughout the sequence. Now let's get started. Okay, in order for sequence 7, 11, 15, 19, 23 so on to be arithmetic progression, we must first know the common difference of the terms should be equal. Okay, as I said before, out here 11 minus 7 is 4. Okay, 15 minus 11 is also 4. So we can say that this sequence, and if you want you can check out, or if I go back, or if you want you can just check out 19 minus 15 is 4, 23 minus 19 is 4. So out here 4 is the common difference and it follows throughout the sequence. Okay, so we can say that it is an arithmetic sequence with common difference equals to 4. Now they have said that we need to find out 27th term of the sequence. For that we will be using the formula, that is t of n is equals to a plus n minus 1d. Okay, now I've rewritten the sequence again so that I don't have to go back every time. Alright, now I can say, okay, alright, now the term that has been asked to me, or the term that I need, is 27. So n will be 27. D as I said that it's the common difference, so d equals to 4, and a indicates the first term of the sequence. Now out here the first term of the sequence is 7. Alright, now what I'm going to do is that I'm going to substitute all values that I have calculated out here, or I have written out here. I will be substituting them into my formula. Alright, t of 27 is equals to 7 plus 27 minus 1 into 4. After some simplifications, I got to know that t of 27 is equals to 111, and this is my required answer, that the 27th term of this sequence will be 111. I hope that you have understood that how to calculate the term that is required if that sequence is an arithmetic sequence. Okay, let's take another example and understand it better. Okay, now it says that you need to find out the 15th term of this arithmetic progression. Now out here they already told you that it's an arithmetic progression, but we need to know that for arithmetic progression the common difference between two successive terms should be equal throughout the sequence. Alright, now what I've done out here is I have just simplified this sequence a little so that it's easy for me. Okay, after simplification I got 11 by 2, 6, 13 by 2, 7 and so on. Okay, now the first term a is 11 by 2 and the common difference d is 1 by 2. Now you can check. Okay, 6 minus 11 by 2 is 1 by 2, 7 minus 13 by 2 is 1 by 2, 13 by 2 minus 6 is 1 by 2. So it's basically arithmetic progression. Already they have written it's arithmetic progression. We just need to find out the common difference, that what exactly the common difference is. Now the common difference in this sequence is 1 by 2 and 15th term is required, so n equals to 15. Now by using the formula we have t of n is equals to a plus n minus 1d. Now what we are going to do is that we're going to substitute all the informations that I have written out here, that is a, d and then into this formula to find out my answer. Now as you can see I have written a as 11 by 2, n was 15, d is 1 by 2. So after simplification this is my final answer, that is 23 by 2 will be my 15th term of this arithmetic sequence. Let's take another example and work and see how arithmetic sequence goes. Okay, now what term of the following AP is 5, 10, 15, 20, 25 is 125. Now as you can see, they already told you that it's an arithmetic progression. What they are saying is that earlier we were told to calculate particular number of the sequence. Alright, they have already given us that dash number of sequence is this. Okay, we need to find out that at what number we get this particular number. Okay, sorry, this particular number is obtained after how many terms. Okay, so let's get started. The solution is, now out here a is 5, d the common difference is 5 and t of n, that is the term is already given, that it's 125. Okay, they are asking us that after what term, okay, that after what number we will get this term 125. Okay, so in this particular question the information has given to you regarding the term, that the term they had already mentioned that it's 125. We need to know that at what number we will be getting this term. Okay, now we will be using the same formula, that is t of n is equals to a plus n minus 1d. Okay, therefore I've just substituted all this information into my formula and it is like 125 equals to 5 plus n, which is unknown, minus 1d, d is 5. Okay, so what I did here is that after just a little simplification I'm just multiplying this 5 with this bracket, so it will be 5n minus 5 now. See, plus 5n minus 5. Now what we are going to do is going to solve it a little. This is positive and negative 5 will be cancelled. The terms remaining will be 125 is equals to 5n. Now it is very easy for us to calculate what n will be. So n is equals to 125 upon 5 and 25 is my answer, that after 25th term we will get 125. So questions can be asked like that as well, that initially we were asked to find out the particular term. In this question we were asked that the term is given to you, they are asking you about the number, that at what position this term will occur, or at what position you will obtain this term, that was 125. Okay, that after 25th position, the 25th position of the sequence will be 125. This is they are asking you about the number of term, that what number of term will be 125. So guys, moving on, we will now be learning about arithmetic series. Okay, the sum of the terms of the arithmetic sequence is called an arithmetic series. The formula for arithmetic series is this: s of n is equals to n upon 2, 2a plus n minus 1 d. Now if a sequence is given to you and it verifies after checking out the common difference that it is a thematic sequence, and now if we wanted to find out its sum, so the sum of a thematic sequence will be is called a thematic series, and will be calculated by using this formula, that is S of n by 2, 2a plus n minus 1 d. Now if L is the last term, that is T of n indicates L, alright. So S of n is equals to n upon 2 a plus L. Now what we are going to do is that we will be looking at some example. We will be looking at an example that we can solve by using this formula, and then we will look another example, and we will be using this formula to find out sum of the thematic sequence. So let's get started. Okay, so the example out here is find the sum to 10 terms of the sequence 3, 10, 17, 24 and 31. Now you can verify that the common difference between the successive terms is the same throughout the sequence, that is 10 minus 3, 17 minus 10, 24 minus 17 and 31 minus 24. They are all same, that is 7. Okay, and they have asked you that we need to find out the sum to 10 terms. Now that means that after 10 terms, what will be, if there are 10 terms in the sequence and we need to add them all, what will be the total of the term of the what will be the sum actually to 10 terms. So this is what they are asking you. So the A indicates the first term of the sequence, D is basically the common difference, and N is the number of term that is required out here. They are asking us to find out sum to 10 terms, so 10 is my N. Okay, using this formula, okay, now what I have done is that I have substituted these three values into my formula. As you can see out here, N, that is 10 by 2, 2a, that is 2 into 3, plus n minus 1, 10 minus 1 into d, that is 7. After simplifying it a bit, I get, if I just cancel 2 1s are 2, 2 5s are 10, 2 times 3 is 6, plus 10 minus 1 is 9, and 9 into 7 gives us 63. So after solving this is what my final answer is, that is 345. Now the sum of this sequence to 10 terms is 345. Moving on. Okay, now they are saying obtain the sum to 11 terms of a thematic series whose first term is 3 and the last term is minus 47. Now they are saying that there is a series of arithmetic, there is an arithmetic series. We need to find out the sum of that series up to 11 terms, alright. And they have told us that the first term of the series of the sequence is 3 and the last term is minus 47. They have not given us the complete sequence. They have just told us that the first term is 3 and the last term is minus 47, and you need to find out the sum to 11 terms. So let's see how can we solve this. In this case, A is 3, A indicates the first term, right? L indicates the last term, that is minus 47, and N is equals to 11 because sum is asked to 11 terms. Therefore I can now use this formula, that is S of n is equals to n upon 2 a plus L. Now in this formula, as you can see, there is no D, so I don't need a common difference to use this formula, alright. So S of 11 is equals to 11 upon 2, 3 plus minus of 47 because L was given as minus 47. After simplification and after solving it, this is what my final answer, that is minus 242. So that means that the sum of an arithmetic series whose first term is 3 and the last term is minus 47, and they have asked us sum to 11 terms, so sum till 11 term is minus 242.